Kerala to be an associate editor of the Springer Journal. And I believe now the contribution of the architectural engineer in this journal will increase day by day. Another significant institutional development that I must bring to your attention is that the Institution of Engineers India has now been recognized as an awarding as well as assessing body under the National Council for Vocational Education and Training, that is NCVET. This is a transformative step which places IEI at the forefront of competency based education and professional certification in India. It enhances our responsibility to shape the future workforce by aligning engineering practice with nationally recognized skill standards. And this is an opportunity for all our centers, the local centers and state centers. You develop the course from any discipline for this NCVT. And if your course development is accepted by the core team of NCVT in IEI, then not only your center, not only the other centers will replicate, but that will provide a financial assistance to your center. So please come forward if you have any idea to start a course. In fact, the course might be is starting. There are different courses, different grades, starting from, and at the top, the courses are for postdoctorate fellows up to the mission level. So any kind of course you can develop, and it can be replicated all through India by the different centers of IEI, which will produce visibility, which will give quite a lot of energy to IEI centers as well as finance. Further, I would like to briefly touch upon the evolving legislative landscape. The proposed Architects Act, you must be all aware, a proposed Architects Amendment 2026 is expected to redefine and expand the professional roles of civil and architectural engineers. I'm really happy to say that already whatever IEI, the Institution of Engineers, especially the Architectural Engineering Division Board proposed for the amendment, everything has been accepted by the Council of Architecture. Entire amendment proposal has been sent to the ministry, and in the last week, the President of Council of Architecture gave a presentation in front of the Joint Parliamentary Committee. So the amendment is on its way, and we hope that when the Higher Education Council bill will come, it will accompanied by the architect, the Architects Act amendment also, because to cope up with the NEP, that is National Education Policy, along with HECI bill, definitely the Architecture Amendment Bill has to be passed by the Parliament. This amendment, in my considered opinion, is a progressive step towards recognizing the contributions of architectural engineers and civil engineers in planning, design, and execution of built environments. Once the amendment is done, all the practicing civil and architectural engineers will be registered under Council of Architects, all the practicing engineers. So it's a win-win situation for architects and engineers, because now on, we all will work together, shoulder to shoulder. It is imperative that we as professionals remain engaged, informed, and proactive in shaping such policy frameworks to ensure balanced and inclusive professional recognition. Friends, the division is also committed to nurturing emerging talent. I am pleased to inform you that the Young Engineers Award 2026 is already, the application we have already invited, and the last date has been increased up to 30th April 2026. Kindly encourage all your friends. The age limit for male applicant 35 years, and for female applicant 37 years. I strongly urge eligible young professionals to apply and showcase their innovation technical excellence, and contribution to the field. Recognizing young talent is essential for sustaining the future of our profession. Coming back to today's program, we are honored to have with us Madam Isha Vate, founder of Anjani Ecological Solutions, as our distinguished panelist, who will share her expertise on ecological restoration strategies. We are equally privileged to have Engineer M. Suresh Babu as moderator, Dr. May Mathu, and our very own Aparna. All are the board members and are very much associated with the technical activities and rather all activities of architectural engineering in institution of engineer. Before I conclude, I would like to emphasize that such technical webinars recognized as continuing professional development, that is CPD programs by IEI, play a crucial role in enhancing our professional competence and keeping us abreast of emerging trends. Before I end, I would like to request all my architectural engineer present here, please apply for professional engineer certificate in architectural engineering. You will be very happy to know that IEI recognized and started giving professional engineer PE certificate to all architectural engineers once their application will come, depending on their qualification, experience, and contribution to the society. So please apply and be a professional engineer. Proudly say I am a PE in architectural engineer. With these words, I once again welcome all participants and express my sincere gratitude to the organizers, speakers, and attendees for being part of this knowledge sharing initiative. I wish the webinar a great success and insightful deliberations. Thank you. Thank you all.
Thank you, Dr. Sandeep Kumar sir. Wonderful explanation about architectural engineering and our institute and other thing. Really, really wonderful, sir. Now, with this, I invite Dr. May Matthew to give some introduction about today's theme of the presentation. Over to Dr. May Matthew.
Okay, thank you. And engineer, respected ARDB chairman, Dr. Sandeep Kumar Deb, ARDB member and moderator, engineer Suresh Babu, and also ARDB member, Aparna, architect, and all other IE and non-IE members who have logged in to listen to the resourceful session. Very good evening to all of you. And the topic of today's technical webinar is Beyond Green Buffers, Ecological Restoration in Highly Modified Landscapes. Our resource person is Ms. Isha Bate, founder, Anjani Ecological Solutions. In this background, I would like to express my fundamental thoughts on this topic and how this topic is relevant in this ecologically overshooting era. World is going through an ecological emergency. On the demand and supply side, world is consuming 1.8 Earth, while we have only 1 Earth. Excess consumption above 1 Earth is going as carbon dioxide and carbon dioxide equivalent, which is in the atmosphere causing global warming, which reflects as climate change and other associated problems of the present era. All these ecological overshoot is caused by anthropogenic reasons induced by linear economy systems embedded with the unplanned and irresponsible consumption pattern. We have to bring our linear economic systems to circular economic system to sustain and to attain sustainable development. I am sure that most of the people present here are sustainability enthusiasts, and I will simplify this world phenomenon by using three terminologies of the research world. One is the Human Development Index, improvised as IHDI, Inequality Adjusted Human Development Index of UNDP, in which health, education, income, as well as inequality dimension is taken into account. And second is ecological footprint and biocapacity calculations of global footprint network. That means at the output side, what we are, the world is going to create output as IHDA, human welfare and progress. That means in terms of health, education, income, and that too in an equitable way. And United, that's UNDP has that calculations which are published in the internet. One can access, and we can see, we can find a lot of things in India. Even though Human Development Index is high, inequality adjusted human development is not so good. That means India has to strive better to attain development by giving equal women through women empowerment. Like that, we can come to so many conclusions by seeing these statistics. And also ecological footprint and biocapacity calculations of global footprint network and world. Then some of the universities, York University has adopted this innovations, and they have also associated with the research. And in the ecological footprint is the demand side. That means how much humanity is consuming. And while the biological capacity of the earth is at the supply side, that means stock. That means um, these three things are, that's ecological footprint and biocapacity calculations are taking into account everything together. That means what all resourceful land we have, and it is adjusted for the productivity of the land, and also the amount of carbon dioxide, that amount of land required for sequestration of carbon dioxide. All these things are brought to a single platform. And also at the supply side, it is known as biological capacity, which is in global hectares. And on the demand side, it is known as ecological footprint in global hectares. And if you are considering these three aspects, very simple, we can find out what is the situation of the world, in which direction we are going. As part of my research, I have developed two strong indicators: environmental efficiency and carrying capacity. That means one is calculated based on an output by input approach, because as far as industry is concerned, we are taken into consideration of the efficiency. And for any systems we can consider this efficiency concept, and in this case world, from the global to local to cities and communities, we can take these indicators IHD by EFP. That's at the global level, we have got the data. And also carrying capacity of the earth, demand divided by supply, EFPI, ecological footprint divided by biocapacity. And I can visualize all the world problems in a simplified way by these, using these two double decker in the umbrellas, that E and CC. CC will be the outer umbrella and E will be the inner umbrella. And through this, and the world is, our earth is under these two umbrellas, and we are eyeing through this fabric, we will be able to understand the situation in a very simplified way. And world presently is ecologically degrading, there is no doubt. Biocapacity is in a downward trend, while ecological footprint is having an upward trend. That means that means biocapacity divided by ecological footprint, carrying capacity is reducing drastically. That is why we are consuming 1.8 Earth while we have only one Earth. Situation is very bad. We have to bring down the calculations and
Dr. Sudeep ji, there is some network issues.
that's development. Miss Isha Bhatte is explaining two case studies evolved from her own experience in the field. And I invite your wholehearted attention to listen to the resource person. Over to Miss Isha Bhatte. Thank you.
Thank you, Dr. Matthew, for your wonderful introduction of the subject. And it gave immense insight onto the subject. Now I introduce the woman of the hour, Miss Isha Bhate. She is a qualified as a mechanical engineer and worked in the research and developments of automobile industry for 6 years. After shifting gears from neutral to second to top gear, she wanted to switch to next gear. There is another gear. That gear happens to be the nature. There she has taken several courses in ecology, botany, designing with nature, global diversity, global diversity assessment, circular economy. Now she found her own firm, Anjani Ecological Solution. Okay. Now I welcome Ms. Isha Bhate to her presentation. Please, come, Isha.
Good evening, everyone. Thank you, sir, for my introduction. And I heartfelt thanks to IEI and ARDB for having me, for giving me this platform where we can share some of our work. Thank you so much. And I thank all the participants who have come here. Thank you for coming. Thank you. So, as May Matthew ma'am has rightly pointed out, that we are extracting so much from the earth that at the current state of consumption, we require about 1.8 earths and we only have one. And so, sustainable development is one thing, but restoration, where we restore the natural resources so that they are available for us first and also our next generations in the time to come. So ecological restoration addresses this over extraction and this imbalance or this overarching ecological distress that we are seeing in the form of climate change or species extinction or other things. It is only because extraction is so much more and restoration is very less. So thank you, ma'am, for setting that context. Okay, so there are roughly two parts to this presentation. One is the context setting and the background of ecological restoration or ecosystemic approach, and second, the case studies. So I'll begin with the context setting. So imagine a landscape, a pristine landscape, undisturbed. And I've just depicted it graphically here and simplified it a bit for ease of understanding and communication. So there are several elements in this ecosystem, in this natural ecosystem, and I will quickly, walk you through them. So this is a undisturbed, pristine ecosystem with ecosystem functions are happening properly. Okay, so if we remove all the biotic factors, all the biota that is there, and go back to what are the abiotic factors, they are the mountains, the rock, the soil, the water, all the physical cycles that are there in nature. So only because that there are abiotic factors, biotic factors can come in, can evolve to be. So even a stone, a rock is important in nature or in the entire connectivity of things. And most often than not, only biotic factors are visible or apparent to a lot of us. But this is the base, the foundation on which the biotic factors come in. So this is a catchment. The earlier landscape that I had shown, this is the catchment. Stream networks joining a stream, that is a stream in the valley. There's rocks and all the other abiotic factors, and slowly the biotic factors come in. Now there are multitude of species, a lot of species there. Certain species are found at certain altitudes, certain are generic species, certain are dominant, certain are generalist, certain have certain species are in large numbers, or certain species are found near the river, they are not found anywhere else. So habitat specialists, certain species are there in only one or two number, even in a big forest, so rare species. All these kinds of different mix is there in an ecosystem. So as I said, abiotic factors and biotic factors, and then a lot of intricacies, multi-layered connections are there between these factors, between abiotic, biotic, and between biotic themselves. Now humans come in. Now imagine this system about 500, this landscape about 500 years back, and say a tribe, a wandering tribe came in. They modified the landscape a bit with, small scale farming, small community living, largely undisturbed, but still some modification has happened. Further, the modification increases. Maybe there's cattle that is there, cattle rearing is happening, and that is the grazing pressure is there, fires are there, landslides are there. There might be some natural factors as well, but humans largely. And slowly the system gets modified, the ecosystem gets modified. Now factor in the battles that happened, the invasions, the various calamities. Now this already modified ecosystem slowly degrades, and with this degradation, a lot of other changes are triggered. For example, a forest which turns to be a scrub or a grassland slowly is denoted as a wasteland. There's nothing as wasteland in nature, but humans denote it as wasteland. And then it's assigned for industrial purposes or SEZs or MIDC, GIDC, etc. Now, once the industries come in, there's full transformation. There are roads, there's industries, settlements, and all that the urbanization comes in, and the natural ecosystem which was there is now retreated back to the pockets. And now look at the smaller elements or the other elements which are plants, because they are visible, they're apparent, more apparent. So with industries, with this kind of land use change comes a lot of regulation and compliance, and they do comply to some extent. So you see there's a lot of plantation being done, but this is entirely different kind of plantation which did not have any relationship or any association with the original landscape is being done. Fast growing, green, dense planted, because in 1 or 2 years it is green. But is it really ecological? Is it really functional? This is not given any attention. So you see all the biotic corridors are broken, the physical corridors are broken, the lower order streams are not seen anymore, the river has turned gray, there's STP directly emptied, STP water or sewage directly emptied into the river, lots of problems. Air is very bad, air pollution is there. So all of that our present scenario. So now coming back to the original ecosystem, this and how a modified ecosystem looks. So this is undisturbed ecosystem, this is the modified ecosystem. It's not still bad because I haven't taken the city photo or the city view, but the outskirts of the city where there are a few hills remaining. Now one may say that this might be from different seasons. No, they are from exactly same season. So this photo was taken in November 2021, the undisturbed ecosystem, and this was taken in November 2021 again, 1 day apart. So undisturbed and disturbed ecosystems, so much difference. Now what are the differences? So all the connections, all the elements in here are disturbed, modified, packaged into a different thing, and in a different avatar, and are seen here. For example, as I pointed earlier, tree species are different, river system is broken, the soil infiltration or the runoff is much more faster because everything is concretized, the soil health is bad, river health is bad, air is much bad. So all the natural processes are now disturbed. Now with this, I'll give one example of the flora species. And we are picking only a handful of species which are found in that forest. So you see the photos here. Let the names be, they are not important. All the photo and all the pictures here, they do not match. So original forest had this kind of plants or flora composition, and the modified landscape has this, and there are some invasive species as well. Now these were trees. Now look at the shrubs. There's lot many more shrubs here, a very few shrubs here. No one is also again thinking about restoration of herbs or creepers, climbers, orchids, fungi, algae. They are forgotten. Now let me give you an analogy, because many of us are engineers here. Imagine a car, a disassembled car. It has thousands of parts. Now what happens if a small part here, or even a smaller, a nut or a bolt, is broken or is malfunctioning? We immediately understand the importance that it has to be fixed. Otherwise, the functionality of car will be compromised. That is very, very apparent to all of us. But similarly, a ecosystem has millions of parts, from the smallest fungi to the multitudes of rocks and physical cycles like carbon and nitrogen cycle, the water cycle, the food webs, so many elements, such diversity, and it is broken every day. Right now, as we are speaking, species are being extinct. So a broken car is, is given attention, but a broken ecosystem rarely gets an attention. Now, why ecosystem is important, a natural ecosystem is important? Because it provides us with ecosystem services. For example, soil for cultivating food, fresh water, timber, medicines, climate regulation, water purification, flood control, pollination, and so many more. Now, we are so much dependent on these services that we will cease to exist if these services are not provided by nature to us. Can we do pollination by ourselves artificially? How much? We cannot. Can we form the soil? No. How do we regulate the nutrient cycling in the soil, or how do we regulate the carbon cycle? How do we look at nitrogen cycle? How do we build habitats? It is best done by nature. And here is some relationships or associations between all these ecological services and the stresses and threats that are there, and you will see a very intricate linkages between all of them. So this is the ecosystem, the natural ecosystems that are there, which we are meddling up with, and we are seeing its ill effects, and at the end it comes to our survival. So all earthlings, including humans, fully depend on natural ecosystem services for survival. And I especially said earthlings including humans because we share this planet with a lot of living beings, the birds, the bees, etc. And we most often than not talk about how humans will benefit, but unless they all benefit, humans will not benefit. So ecosystemic approach. For example, coming back to the first photo I had shown you of the landscape, this is the Google Earth imagery. So the project site is here, small, highlighted in orange, but we look at the entire landscape. What are the flows and connections? For example, water, soil, flora, fauna. How is the seed dispersal happening? What are the stresses on the land, etc. And then we compare with it with a reference ecosystem, that is a protected ecosystem, the undisturbed site photo I had shown earlier. So this site essentially was like this before degradation. So how do we go back? What are the pathways? This is where we work. So it's essential to look at the landscape flows and connections and have a reference ecosystem. Now this was about the ecosystemic approach. Now let me come to the green buffers. So most of us, like all of us, love plants, love plantation, and it looks like this. So there's a small problem here, because this is man-made plantations, and this is how the uh, floral diversity succeeds via natural succession in nature. So core differences: There are multiple layers here. There are no straight lines. There's no there's diversity of age, diversity of height. Soil is covered. So what happens with this diversity? If you have one, two, or a few species planted, and see, say one species is dependent on or associated with 20 odd fauna species, only these 20 fauna species are going to find a home on this land parcel, which may be hundreds of acres in that region. Okay. And otherwise, there might be 300, 400 other species of fauna which are dependent on this kind of floral diversity, but it is not there. Now, similar plants or lesser diversity in plants will also have lesser diversity in the root structures, how the water percolates, what is the soil microbiota that is attached to this roots. All of that get affected. In our haste of faster plantation development and greening the landscapes, we compromise biodiversity. And on the right, you see there are multiple layers: grasses, herbs, shrubs, trees, climbers, lianas, orchids, and fungi, etc. Diversity is there in height and age. Corresponding faunal associations are maintained. Ground cover stops soil erosion, wind erosion, etc. And yeah, it's resilient towards stresses like floods and foreign species invasion. So this is why greening or plantation is not a solution, so ecosystemic approach is one. Then going beyond green buffers is this, and now introducing natives and non-natives. So for faster results, often non-native species are introduced in plantation, and they have a lot of stresses induced on any landscape. They might be invasive, they might not degrade. Their checks, the natural checks and control mechanism in nature may not be applicable to them because the related associations, they come from a foreign land. It might not be there. For example, eucalyptus, which comes from Australia, does not have, it degrades very slowly here because the microbiota associated with it is not found in Indian soil, Indian different types of Indian soil, things like that. So the native biodiversity has another level of threat from non-natives. For example, a common Ashoka tree everyone knows in India, this is a non-native, and the real Ashoka, Sita Ashoka, Saraka Ashoka, is this one. For example, another tree, Subabul, it's a non-native and invasive. So it was introduced as a fodder crop or for fuel, but it has taken over vast major of land, turned all this Kailashpati. They name it such that people would be interested to buy these plants and plant in the gardens or their homes. But again, this is non-native. And with this context, I want to come to rewilding industrial landscapes, because these are one of the most modified landscapes, industrial, SEZs or the industrial areas. So how do we rewild them so that there is some ecological restoration? Only stresses or extraction is not happening, but restoration is also happening. Most of this manufacturing industries have huge land parcels, 500 acres, 200 acres, so they also have good potential. And also there are compliances that 33% or more than 20% of land should be under green belts. So that kind of compliances also help. So let me bring some real life data. Industrial site 1, this is in Maharashtra, about 200 acres of site, and we've looked at a lot of natural parameters, which is total plant species. So on the project land, about 228, and on the modeled reference ecosystem. So reference ecosystem is undisturbed ecosystem in that region. Model reference ecosystem is one where you have so much modified landscape that no patch of land is protected or undisturbed, at that time you have to go back, look at the historical data, look at the papers, and simulate a model the reference ecosystem. That is how we arrive at these numbers. 344. So overall, very less diversity. In this, 139 are native species, but in the reference ecosystem, 286 is a 52% deficit. Non-native species, so there's a lot of invasion outside of the industry. So about 87 species, similar species here, which means that all the invasive species are thriving. Their exchanges of seed dispersal via wind and water is happening more efficiently. It's almost the same numbers are here. Most of them are planted or they regenerate faster or both. So comparable numbers. Native tree diversity. So out of this 220, out of this 139 native, 36 are trees, because others, shrubs, herbs, etc., also are there in this 139 against 80. Shrub diversity 11 by 45. So you look at this, 55% deficit and 75% deficit. Fauna, all the birds, butterflies, bees, mammals, and this is documented. There is a lot which is undocumented. So 112 against 350, 60% deficit. Soil is polluted, water is polluted, air is polluted. Outside as well, it's polluted, because this is again not a protected ecosystem but a modeled ecosystem. That is why. So all the natural parameters that we can work with, not not performing well. So highly modified landscape. Similar example, industrial site 2, again in Maharashtra. You can see 55% deficit in native tree diversity, 75 in shrubs, and 60% in fauna. Overall, same trend. Now, how do we work with these lands? This is the land parcel. It's situated on a ridge or a water divide. So a lot of lower order streams uh, originate here, and they lead up to rivers on both the sides. Now, when something is constructed uh, on a water divide, a lot of, because of the altitude difference, a lot of cutting and filling of earth is going to happen. So this parcel is about 160 acres or about 200 acres, and the factory here spreading across 40-45 acres, all cutting and filling of 8 meters or 10 meters has happened. So to fill this earth, you have to dig somewhere else. You are creating erosion at some place else. Completely different plant composition. Invasive species are spreading. Fauna, only the very general hardy species like crows and bulbuls are there. Some migratory birds are still there because there are some good water bodies here. So thankfully, they found a habitat, and the migratory species still come. Soil is bad, eroded, open. All the dust and emissions settled on it. Groundwater is depleted. There's very less chance for recharge, because this is one parcel of land, but this is a MIDC. So a lot of other industries are in the neighborhood, and more the concretization, lesser the water population that is happening. So groundwater is affected, and extraction is happening at much more higher level, because there are farms on the downstream. Air pollution, dust emissions, all of it is there. So with this problem statement we begin. And as I said, because we look at the ecosystem, this is the industrial area. The project land is here, but we look at the entire catchment. What are the flows and connections? What is the land use? What are the stresses? What are the flora composition, fauna compositions? We do transit surveys, compile all that data, model the reference ecosystem, and then try to bring in the interventions. So it starts with ecological assessments, followed by interpretation of the data and research about it, translate the data into ecological interventions, plan this properly, do capacity building of the teams, and then do the execution. So the interventions, the set of interventions that we are given here for this particular land parcel. So these are factory sheds, already modified land. We cannot do anything here. But about 60 acres of land on this 200-acre parcel remains, where we can work, with nature. So we have removed the invasive species, and we have rechannelized those, as ma'am said. using circular economy principles, rechannelized the biomass which is generated or which was here on the land back to the soil, because nutrients are extracted, we have to give it back to the soil. So via biochar, via mulching, via composting, addition of FYM, etc. We created habitats for IUCN listed or migratory birds, and we've created a mosaic of ecosystems. You see, there are grasslands here, there are woodland type of plantations here, there's a butterfly garden, there's an edible garden, in between there is natural hedges around, and a multi-tiered green belts, so that the air pollution is also taken care of. So this landscape or this land parcel now becomes a stepping stone in the larger landscape, where the biodiversity can find a home. And if several such stepping stones are there, probably corridors can be restored, and some functionality which we have lost in the process of extraction will also get restored. So, how do we do this? Native green belts. We have multiple ponds here for collecting rainwater, but these ponds are not with straight edges or tanks. So they are made in the form of wetlands with shallow edges and a lot of aquatic vegetation, so that the habitats for migratory birds remain. There are islands in this, etc. Uh, we also do a lot of biocharing. Butterfly garden is there. So all of these interventions have been given to the industry, and these interventions take uh, 3 to 5 years for execution, because you have to do earthworks and about 60 acres of land and plantation. So transformative results will take time, because we are working with the pace of nature and not against it. And we strictly do not do dense plantations, because dense plantations are not functional. And if, for example, if 100 species are planted in dense plantation, only 10% or 12% species, they are able to thrive, and others are just suppressed because of the physical design of the dense plantation. It will appear green but will not have functionality. So green belts, we design green belts with native species. For example, this is one example of the green belt. The way we have designed it is 120 to 140% more effective for dust screening, with the kind of tree morphological factors that we've used. So certain species are very good at uh, accumulating dust than certain other species. So we've used the native species. We have done a matrix of various parameters, their performance about dust screening, and on the periphery we try to plant this kind of structures, or they will grow in this kind of structures, so that maximum dust attenuation can happen. Some examples, because we work with natives only, working with grasslands, working with soil, all these are our native plantations. This is, I mentioned about the multiple water bodies in the form of wetlands, and the small swales which come from the uh, undulating landscape. So they collect water in rainy season, empty into this. So all of this is connected with islands. So this the industry's intent of water neutrality is also served through this. Biodiversity as well as the functionality is also uh, attended. So some habitat restoration via log piles, stone piles, brush piles. There are other methods as well. So these are habitats for reptiles and birds, ground birds, and it's best that they are there outside rather than inside. So if there is a hide made for them outside, unlikely that they will come inside, because we have disturbed their habitat, they will come inside. We work on soil. So soil is like this, open, and emissions and dust settle on it. So when invasives are removed, we channel it back through biochar or mulching, so that there's natural regeneration of native species. Butterfly gardens. So these are some of the photographs from various native species that were used, and the layering that we've done, and the butterflies or bees or moths or other smaller friendly insects that have come in. One other challenge that we encounter is native species are not available in commercial plant nurseries. So, at many of our projects, we set or establish our own native nurseries, and for this, we have to go to the forest. So, when we do the flora, fauna, biodiversity assessments on ground, and we collect the seeds from nature, make a seed bank, and then slowly start propagating these saplings ourselves, because there's no supply chain, or very few nurseries exist which deal with native species. So we have to establish these kind of nurseries. We have to train people, because most of them only know inorganic methods or commercial plants. So we have to train them to get or grow a natives nursery. So now coming back, so after interventions, what is the trend at our industrial site 1? So native species were 139 out of 286 from a model reference ecosystem. And we have done planning in such a way that the count will increase to 242. So of course, we cannot go back to all the species, because some species are really very difficult to propagate or bring them on the land. But 242, we are much closer than we were earlier. Non-native species, so invasive ones, we phase them out, and non-invasive ones, for example, gulmohar, it's a non-invasive, non-native tree, so we let it be. Like that, others as well. So this doesn't the non-native, non-invasive doesn't hurt, we let them be. Tree diversity is from 80 to 75. So 30, 80 in the model reference ecosystem, 36 on the land. Now it will have 75. Shrub diversity to 38. Fauna will increase, because as soon as soil, water, trees are established, fauna comes back. And when fauna comes back, your interventions have worked. So soil, we have taken this restoration steps. It's going to take some time to restore it. Similarly with water and air, but we are on the way. Now coming to our second case study. So this was industrial land parcels, and now coming to private land ownerships, where people want to do cottages or resorts or farmhouses or things like that. So again, we work with an ecosystemic approach, and all the site analysis, standard set of site analysis, slope and drainage, etc. We'll work at them. This is the land class or land class mapping that we've done. So site has a lot of grasses, it's degraded, it has three major streams, and all this light green color is grasses. These are tree clusters. So this was a forest before, degraded to a kind of grassland plus few tree clusters ecosystem. And the owner wants it to be ecological, semi-commercial kind of setup. So we have identified locations where they can have their cottages and other building footprint, but on a whole lot of area, we will be doing native plantations, which will cater to fruit trees, wild fruit clusters, grass. We will retain some grasslands, because erasing or not having the grasses is also not going to help, because grasses restore the soil very well. Karvi, you might know Nilan Kurunji, the flower that blooms every 12 years in Kerala. The same, that species in Maharashtra, it blooms every 7 years. So that and Karvi naturally grows in this region, but on these slopes, it was not there. So we've collected the Karvi seeds and asked the owner to plant it on the steep slopes, so that a Karvi covering is there, which will ensure a lot of ecosystem functionality. It contains fire, it helps soil microorganisms, etc. So that has been planned. Natural hedges, so you see this yellow border across the land, it is all natural hedges, so that a lot of habitats are formed for birds and smaller animals. When birds come, they bring a lot of seeds, they improve the soil, so all that interactions will get triggered. Riparian zones, that is near the streams, we've given separate treatment for that. Flowering clusters. So I've put some photos, and this is proposed. This is not yet happened on the land. We are trying to execute it. So natural edges. One species is bamboo, but multiple others. Carvey on the hill slopes, as I said. Fruit grows. So the regular fruits that we all know, but these are the wild fruits. So taking the seeds from the wild and sowing it there or propagating it there, and all the native flora, because it comes with a lot of pollinate. The pollination is pollinators are supported, birds are supported, so all of that ecosystem benefit you get. So this is about the private landowners. Now with this approach, we work with ecosystem approach and try to do restoration in various landscape, be it community lands or industries or private lands or government land, etc. But some fundamental roadblocks that we are facing, one is lack of awareness, and forums like this give us platform. So thank you very much again. Greenwashing. So how do you argue with people who are going to say that we will create a forest for you within 2 years, dense plantation, 50,000 plants in 5 acres? So it all sounds so good that one is not able to contradict it or question it critically. So this kind of greenwashing is rampant. Or they will say that no, no, we work with all native species, we will not even do dense plantation. But what native species? This might be very, very generic 50 odd native species. So people who do not know the ecosystem, who have not done the ecosystem or the ecological assessment of that area, and if they are trying to give interventions, then people like us who are aware should question budgets, because everyone wants faster results. 5 acres, 50,000, and I'll tell you, for 50,000 trees, about 50 about 1,000 acres of land is required, because a land with forest systems that are in India, and the top of envelope calculation, uh, 1 acre can accommodate about 100 or 200 odd trees. And we are talking about 50,000 trees on 1 acre, 5 acres, which is like 10,000 trees on 1 acre. So we are actually killing it by doing this kind of plantation. Then budgets, yes, budgets and intention. Then human systems, the industries that we work with or other people, so many, uh, systemic roadblocks are there. There's human inertia. Even if we do the planning, it may not get executed as we have planned. There might be site constraints, which we understand, but then again, human systems and inertia is there. And proper policies. So sometimes policies are there, but they are not ecologically sound, and the client will still have to comply to them, because it's mandated by law. But policies also need to be modified. One other example of greenwashing. So there's a huge riverfront development that is happening in Pune, and we had done a pre-assessment before this is going from 5 years. And before 5 years, we had done some assessment that how a natural river functions, what are its components, and the firm which has taken up this restoration, in their huge 200 odd pages report, they did not even have mention of biodiversity, ecology, riparian zone even once. Now they've offloaded the development to several other firms. They've done the master planning and offloaded small bits and pieces here and to different firms. Now, if you read, so I've taken this from Instagram handle of one such smaller architectural firm which has developed the landscaping here, and I've on purpose not given its name for the privacy, you know, to maintain the privacy. Now they've written that all the ecological restoration, biodiversity enhancement, everything they have taken care of. But here, by the look of it, by the pictures, we've been there, not even 10% of the species are native. All the slopes are modified so much so that the water is going to come fast, so faster on these slopes. The islands here are not given proper treatment. There's a lot of concretization, and on these steep slopes, there is less than or very few inches of soil that there is. There are, various layers of fabrics that are put on the soil. So the roots do not have soil depth to penetrate. So this is all, plastic. This is not ecological. But the terms they use, anyone can get greenwashed. So it's very scary. And as against this, if you go to another handle, I will not give the name, but ecologists who are protesting for this kind of development, they will tell you the truth. But the common man is unaware or cannot make a decision because both the sides are using similar words, but only one can be true, right? So awareness, education has to be continued. Okay. So that was one last part, and so what can a quick takeaways or quick implementation that can happen in urban planning is that lowest hanging fruit is native plantation, but proper native trees, please, not banyan and people. They're not there everywhere. Neem. So yeah, appropriate native plantation. Look at the corridors, green belts, etc. Enough width. Say no to invasives. Protect natural drainage. So obviously, do not build in floodplains because floodplains are one of the most encroached spaces in our country. So these buffers are to be retained. Otherwise, always there will be flooding. Functional STPs, ETPs, so that the water that enters the streams or the river is cleaner. Groundwater recharge zones should be free of encroachment. And there are maps, especially for Pune, they've developed a very good map where you can see which region where groundwater recharge is happening. So this kind of groundwater studies can be done, taken by the developmental committees. More softscapes to counter hardscapes, which will slow off the runoff, reduce heat island effect. Soil restoration, sustainable lifestyle. It's very easy to say, but for us to follow the sustainable lifestyle, it's not so easy. It's very difficult to live sustainably day in, day out. And as in the beginning, we discussed that architects and engineers, when they work together and create different marvels in the world, also include a third aspect, which is ecologist, because unless we see all these connections in a landscape, they will be compromised simply because they're not visible or they're not apparent to everyone. So with this, I will like to thank you once again uh, to ARDB for having me over, and would like to end with every living being or everything is interconnected in nature, and all life is required to sustain all life. Thank you. So if there are any questions, I would be very happy to take those.
Thank you, Isha, for your wonderful presentation. I liked most of the thing, especially when you compare with the automobile with the actual nature. It is
Yeah,
really, really wonderful. We care about a small car, but we don't
yeah,
care about
yeah,
our nature. Hmm? That is
yeah.
that comparison is something wonderful. Now, I would ask our. I think there are few questions already came in the chat box. Huh? Sudeep ji, if somebody wanted to ask directly, you can unmute them and they can ask. Otherwise, whatever is already come in the chat box, I can just read for you. Hmm? One is from Mr. Ajay Nair. He's asking, there is a vast array of satellite or UAV based multi sensor remote sensing data with the temporal uh, archives and analytics are already available for biosphere or biome. The terrestrial data does not give spatial context of this biodiversity by itself. The ecosystem have spatial and vertical character for sustainability. Your views, please.
Yes, sir. I agree. This kind of data is available, and in many projects we look at this data, but we also complement it with ground truthing because, as you said, the granular details, especially for biodiversity, are not visible or are not there to a greater detail. So we always complement it with ground truthing.
Okay, can I read the next question?
Yes, sir, please.
Yeah, that is from Wesley Pereira. He's asking, the forest ecosystem accounting framework quantifies forest assets, biodiversity, and services such as carbon storage and water regulation. This help in assessing the economic benefits of forest. Thus, this habitat restoration project aligns environmental data of the catchment areas with economic reporting to measure climate resilience by tackling environmental degradation of the forest lands and the river ecosystem.
Sir, this is a fantastic point. Actually, this is what is to be done. That what is the ecosystem services? What is its valuation? And as against that, what is the degradation and how much are we losing? But enormous data teams, huge teams are required to, huge scale is also required. So if we are working, say, on a 150, 200, 500 acre of land, these catchments are huge, a few thousand hectares. So it should be done. It is done at some scale, but it should be mainstream. And most often than not, we do not get budgets to, have the capacities to get this data and compare it with the degradation. So there's a mismatch in this. The intent is not there, maybe at some places. Budgets are not there. That kind of scale is not available. But yes, this is happening and this should happen. This should be mainstream. For
Okay.
example, recently they calculated what are the ecosystem services that the Pune rivers are offering, for the city dwellers from past so many years. And it runs into trillions of dollars. And what the degradation is doing. That study was done by IISc, scientists from IISc Bangalore, and they published a paper. And it was mind blowing. So more of these studies should happen, sir. Definitely.
Wonderful. One more question I will take, that is from Sarvesh Prajapati. He is asking, how can ecological restoration be integrated into small scale residential construction projects in India?
Yes, there are some size constraints to this, because if a land parcel is, say, a few hundred square meters, that is not even a half a acre, then we do not have open land. But at least, you can uh, look at the points or the commons. This is where the commons come in, the common resources, that is, the parks near you or the roadside plantations. So we have to tap into that. Smaller land parcels may face challenges, but the bigger land parcels which are under, residential projects, definitely can, uh, a lot of interventions can be implemented there. In bigger land parcels, smallers do have challenges. Fully agree.
Thank you very much, Isha. Well answered. Now, I think we are already overshooted our time. Hmm? I think there are a few people raised their hands also, but due to the time constraint, I think we should be, we should, conclude this webinar. Now, for concluding the thing, I invite our young lady architect and member of Architectural Engineering Division Board, Miss Aparna, to deliver vote of thanks. Please, Aparna.
Good evening, everyone. It is a privilege to propose the vote of thanks for today's very insightful webinar, Beyond Green Buffers, Ecological Restoration in Highly Modified Landscapes. First and foremost, I would like to extend our deepest gratitude to Ms. Isha Bhate, founder of Anjani Ecological Solutions. Thank you for sharing your profound expertise as a restoration ecologist. Your insights into meaningful ecological restoration in our built environments are incredibly timely for architectural and engineering communities today. Your session was deeply informative and really emphasized the need to work with the existing ecosystem for the most sustainable outcomes. I would also like to extend my sincere thanks to Dr. Sandeep Kumar Deb, the chairman of the Architectural Division Board, for presiding over this session and for his constant encouragement in promoting innovative architectural practices. A special word of thanks to my fellow members of the Architectural Division Board, our moderator, Engineer Suresh Babu, and Dr. May Matthew. Your efforts in identifying such critical topics and ensuring the smooth execution of this digital platform is greatly appreciated. I also extend my sincere thanks to Sudeep Chakravarti, Deputy Director of Technical, for helping us with the technical aspects of today's event. Finally, I would like to thank all the architects, engineers, students, and other professionals in attendance today. Your active participation and engagement are what make these sessions truly successful. Thank you all for joining us. Have a wonderful evening.
Thank you. Good evening, everyone.
Thank you. Thank you.
Thank you. Dr. Sandeep sir, can we conclude? Okay. I think, thank you everyone. I think we can conclude here.
Thank you. Thank you.
Yeah, our webinar is concluded. Thank you.
Thank you so much.